So today is the third day on triangle congruence by side, 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 angle, and angle, angle, side. This is the first proofs day. With these triangles, we'll be spending the next couple of days working on proofs. So that's why the learning target says I can prove two triangles congruent using the side, 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 angle, side, and angle postulate, and angle, side theorem. So if you have them, colors today are very, very helpful, more so than any other chapter, I think. What I'll be doing in proofs is I'll be using red, green, and blue for the three congruent parts, and black saying how the two triangles are congruent. So if I were you, pause the video and get out those colors. For every reason to prove triangles congruent, for example, side, 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 you need one congruent side, another congruent side, and another congruent side before you can show the triangles are congruent by side, side, side. For side, angle, side, you need two sides and an angle. For angle, angle, side, and angle, side, angle, you need two angles and a side. So as you're going through the proof, we're going to try to get those three things, either three congruent sides, combinations of sides and congruent angles. So let's start off our proof. Every single proof I start off with the color red because I'm trying to get a congruent part. As usual, for every proof, you want to look at your givens. These ones are already written in there for you. Angle A is congruent to angle B, and that's given. That is a congruent part, a congruent corresponding part in these two triangles. Angle A is congruent to angle B. Notice how I'm marking it in the picture. Another given I have is another congruent part. I have AP congruent to BP, and that's given as well. So AP is marked with a tick, PB or BP is also marked with a tick mark. So notice how I use red, green. Now I need a blue congruent part. But my next step is blank. So I'm going to have to look at this picture to see if I can figure out if anything else is congruent. So just like the other day, remember we talked about vertical angles. Remember when you organize those triangles on your desk, you can assume those two angles are congruent because of the vertical angles. So what you're going to write is you're going to write angle APX is congruent to angle YPB. Okay, and the reasoning is because of the vertical angle theorem. Notice I didn't say angle P is congruent to angle P because I'm not sure. If I say just angle P, I'm not sure which angle I'm actually using. So I need to use those three letters to be specific on what angle I'm using. Now, after I have my three parts, I have the red, green, blue, I'm going to move on to congruent triangles. Notice what I need to prove is what is last. That's true for every single proof. So I'm going to write triangle APX is congruent to triangle BPY. Now my reasoning that goes here is either going to be the side, 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 angle, or angle, side. So that's why it's so important in this proof to mark up your picture, because then it's a lot easier for you to tell which reason to put there. So notice I have two angles and a side in between. Okay, I have an included side. So the reasoning for this one is ASA, angle, side, angle. This next proof, the first thing I'm going to do, and the one I didn't do on the other one, is right away I'm going to write what I need to prove last. So triangle JKM is congruent to triangle LMK. That always goes last. What you need to prove is always your last statement. Right, now I'm going to approach this proof just like the last one. I'm going to start with red. Sure enough, I'm given a congruent side. I'm given JK is congruent to LM. That is a congruent corresponding part, so I'm going to move on to my next part in green. I'm also given another side. This is a nice proof. I have JM congruent to LK. All right, so I have 2 out of the 3 congruent parts. Now I need my third. My third is like what we were doing the other day, an assumed congruent part. And you'll be using this reason quite a bit. When you see a shared side with both triangles, you can assume those 2 sides are congruent in each other. So I would say MK is congruent to MK, and the reason for that is the reflexive property of congruence. So make sure you have property of congruence there. So the 2 reasons you're probably going to come across quite often with these are the reflexive property when they share a side, and vertical angle theorem when you see that X. So that's kind of a little clue if you're trying to find out or trying to find another congruent part. All right, so I have my 3. I went through red, green, blue. Now I need to decide how these triangles are congruent. Notice I marked up a bunch of sides. All the corresponding congruent sides are congruent. So this is going to be side, side, side. Hey, next one. This one starts getting a little harder. First, I'm going to write out what I need to prove. That always goes last. So triangle ADB is congruent to triangle CBD. All right, now I'm going to start with red. Oh no. We have AD parallel to BC. That's not something congruent. That's something parallel. So what I'm going to do is I'm going to use this information that AD is parallel to BC to come up with another congruent part. For me to prove triangles congruent, I need 3 corresponding parts congruent. So what I do is I'm going to extend AD and BC. Notice I have the arrows. Okay? And I'm going to have to try to pick a transversal to see if I can get some congruent angles here. The trick with this is to pick the transversal, because you see how there's 3 lines that could cross those red ones? Pick the transversal that's touching both triangles. So this transversal is touching both, and it might be easier for you to see once you highlight this which angles are congruent. So notice I have that angle 4 and angle 2 congruent. And that's what I'm going to write. So angle 2 is congruent to angle 4. And this is back to your chapter 3 proofs. You see parallel. So parallel then, and then you have to decide what kind of angles 2 and 4 are. 2 and 4 are alternate interior angles. So I'm going to write alternate interior angles congruent. Once I have a congruent part, I'm done with red. Now I can move on to green. And thank goodness this one's given. And I'm going to mark it up. So what I like to do is kind of erase some of this as I go. Or to make sure I still have those markings, so I don't mess that up. Move on to green. I have AD congruent to BC. All right, so green's done because I have a congruent part. Now I'm moving on to blue. All right, so I didn't have anything with parallel above it, so this is where I'm going to look for my go-tos. That's what I call them, go-tos. Okay, if you're listening to this video, to get a stamp or a sticker is you need to write go-tos on the top of your paper. So write go-tos on the top of your paper, because that's an important strategy for these. Your go-to proof reasons are the reflexive property of congruence when they have a shared side, and vertical angle theorem when you see that X with the triangles. In this case, I see that they share a side. So I'm going to write BD is congruent to BD by the reflexive property of congruence. Now that I'm done with blue, I can say that my triangles are congruent. So this is where I'm looking back at my picture. If I'm looking at these two separate triangles, okay, so here are my two separate triangles, I see that I have two sides and an angle, but that angle's included. It's in between the two sides. So the reasoning for this one is side, angle, side. Next proof, same thing as the last one. Write what you want me to prove last. So triangle EFI is congruent to triangle HFG. And here I go again. I'm going to start with red. So I have a congruent part. Sweet. I have IE congruent to GH. So that's a congruent part, so I move on to green. EF to HF are also congruent. Okay. And then, so I can move on to blue, and it says F is the midpoint of GI. All right, so I have to look at this picture here. So if F is the midpoint of GI, okay, I have to think of what that means, midpoint. Well, the definition of midpoint tells me that it's a point that divides a segment into two congruent parts. Well, perfect. I need congruent parts. So I'm going to say that IF is congruent to FG. And the reasoning, back in our chapter 2 proofs, you see that vocab word. The reason is going to be definition of a midpoint. Now that I'm done with blue, I can see why the triangles are congruent. Well, I have a bunch of sides marked up, so this is side, side, side. Next one, write what you want to prove. So triangle ANX is congruent to triangle GRX. And here we go. Notice how the proofs are getting a little harder. Okay, they say X is the midpoint of AG. That's not a congruent part, so I'm not going to move on to green yet. I need to use this statement to come up with a congruent part. So X is the midpoint of AG. Where's AG? Here it is, A and G. Well, just like the last one, if X is the midpoint, it divides that segment into two congruent parts. So what I'm going to write is AX is congruent to XG. The reasoning, look at that vocab word, definition of a midpoint. I have a congruent part, so I can move on to green. Okay, X is the midpoint of NR. Well, that's not a congruent statement, so I need to stay with green and use that statement to come up with something congruent. So X is the midpoint of NR. If X is the midpoint of NR, that's kind of like the same thing that was going on with the other one, only on a different segment. So what I'm going to say is NX is congruent to XR, and again, the same reason. They said it was the midpoint. There's that vocab word. This is going to be definition of a midpoint. I have a congruent part, so I'm done with green. Now I'm going to look at blue. All right, well, there's only one space left. There's no more midpoints to work with. But if I look at my picture, I'm going to use one of my go-tos. I see that X made with the triangles, so I can conclude that those two angles are congruent. Now I'm not going to say angle X congruent to angle X because there's a lot of adjacent angles surrounding X as a vertex. So I'm going to be very specific in naming them. I'm going to say angle AXN is congruent to angle GXR. I'm going to need, and you have to write those three letters. And the reasoning then is vertical angle theorem. All right, blue's done. Now I'm off to black, and now I'm looking at my picture. I have two sides and an angle, and that angle's included, also known as in between. So this is going to be side, angle, side. All right, here we go, another parallel one. But first, write what you need to prove last. Triangle ABC is congruent to triangle CDA. And now I'm off back to red. Good, they gave me something. They said angle B is congruent to angle D. Well, that's a congruent part, so I can move on to green right away. Number two, they give me parallel, nothing congruent, so I have to keep with green. I'm going to use that statement to come up with another congruent part. So if AB is parallel to CD, so notice I'm using that trick where I highlight them so it's easier for me to see. And then to pick a transversal, use the transversal that's touching both triangles. That's my little rule of thumb for this. And it's a little easier now for you to see that angle 3 and angle 2 are congruent. So angle 3 is congruent to angle 2 because they're in alternating positions on the transversal and in between the parallel, so alternate interior angles. But remember how we write that reason. We're going from parallel to congruent, so we have to go parallel then and say the reason why they're congruent. So I'm going to write alternate interior angles congruent. I have a congruent part, so I'm going to move on to blue. So I erased the lines that I drew, just like how I would with my pencil, and redrew my markings. Now I need my fourth congruent part. Here's a go-to. I have that side they share. So I'm going to say AC is congruent to AC by the reflexive property of congruence. Now that I have my three congruent parts, I can now decide how my triangles are congruent. So I have two angles and a side, but there's two of them like that. There's the ASA and the angle side. I have to pick which one. Well, the side is not included. So if you just look at this one and the markings, notice how that blue side is not in between my two angles here. So this reason is going to be angle side. Next one, write what you need to prove last. Triangle SRP is congruent to triangle QRP. And here we go, start with red. Angle S is congruent to angle Q. Mark it up. All right, here we go. There's a congruent part, I can move on to green. Number two, RP bisects angle SRQ. Bisects isn't congruent, so I have to use that to figure something out. So RP is a bisector. So here's RP, and it's bisecting SRQ. So where's SRQ? SRQ. Okay, so bisecting means to cut into congruent parts. So that's good, it's congruent parts. And these congruent parts are angles 2 and 3. So angle 2 is congruent to angle 3 by, back in chapter 2, definition of an angle bisector. So I'm done with green. I have a congruent part. Now I'm going to say another one, and it looks like it's one of those go-tos. I have that same side, that shared side. So PR is congruent to PR by the reflexive property of congruence. Right? I have 3 congruent parts. Now I have to look at my picture and decide why they're congruent. I have 2 angles and a side marked up, but the side is not included, so this is angle, angle, side. All right, last proof. Looks like the hardest, super long. So I'm going to write what I need to prove last. That doesn't change. So triangle PQT is congruent to triangle RST. All right, here we go. Here's red. Perpendicular. Well, that's not congruent. So I got to use that somehow. So they say PQ is perpendicular to RS. So here's PQ, here's RS. Well, if things are perpendicular, I know that creates right angles. So I am going to say that. I'm going to say angle Q is a right angle. The reason is because I saw that perpendicular symbol. And when I saw that, that was that little trick to say definition of perpendicular lines. Well, that's not a congruent part, so I'm still with red. So I'll just keep going. Here's another perpendicular. So I have, where's RS? It's perpendicular to QS. Well, it looks like I just got another right angle, so I'm going to say that. I'm going to say angle S is a right angle. It would be the same reason as the other one. I see perpendicular, so I know that's going to be definition of perpendicular lines. But it's still not a congruent part. So I'm still with red. But if these 2 angles are both right, doesn't that make them congruent? It does. So angle Q is congruent to angle S. That reason is back in chapter 2. The reason is all right angles are congruent. So there's a lot of red on that one. So now that I finally have a congruent part, I can go on to green. Okay, there's a blank here. So I'm getting confused, but oh wait, remember all those go-tos? See that X? These 2 angles must be congruent. So I'm going to say angle QTP is congruent to angle STR. I have to use those 3 letters because there's a lot of adjacent angles surrounding the vertex of T. Versus with Q and S, I could just use the 1 letter because there's no adjacent angles with that same vertex. All right, so what was the reason for that? Vertical angle theorem, one of our go-tos. Okay, now green's done because I have a congruent part. Now I'll move on to blue. That's not congruent. Oh, geez. So now I'm going to have to try to figure out how to use that. So if T is the midpoint of PR, okay, well, we did midpoint already. That tells you congruent segments. So I'm going to say PT is congruent to TR by, use that reason before, you see that word, this is going to be definition of a midpoint. Right, finally, we have our 3 congruent parts. Now I have to figure out why they're congruent. So I have 2 angles and a side, but between these 2 again. So the side is not in between the 2 angles, otherwise it'd be right here, but it's not. So this is going to be angle, angle, side. All right, you finished your first day of proofs. Hope you did okay. Okay, 24 minutes. Whew. It's a little rough, but
Yeah, well, that's a long lesson.
yeah. But then they can look back on it and figure it out, because some of those first ones, they don't need, they could probably fast forward some of it anyway.